Okay. So how went your homework last week? How went the Canon? Good? Motor crash. Crashes happen. Yep, that's unavoidable. I wanted to start the day kind of with an exploration of how we potentially could put together some of these parts and pieces. And specifically, I wanted to spend some time talking about the thought process behind the 3D modeling pipeline, because that's really the most challenging bit behind creating these wonderful sculptures, is going through a sequence, okay, and being able to project yourself through that sequence from A to Z. That's the tough part, right? Now, when it came to creating the sides of our cannon, the little frame that our cannon was placed in, how did you guys approach that? What were some of your big thinking ideas? And I'm just going to load in an image real fast. Oops, I forgot to put it on my desktop. Excuse me. Here, I'm just going to put the side image on my desktop real fast. Oh, that's the top. Let's go back into that. Here we go. Let's try grabbing the right one. There it is. If we jump back into Modo, let me just load it in just so we have a good visual point of reference as to what we're going to be speaking towards. There it is. Cool. All right. So here's our side reference image, and while I'm here, I'm just going to increase the transparency a little bit so we can see through the image into the model that I'm going to create behind it, right? So what was your approach? How did you create the side here of your cannon frame, this big piece? Not the barrel or the wheels, but how did you approach creating the side? Yeah.
I use what was it called? Loop slice.
Loop slice, okay. In what capacity? How did you use it?
Well, with edges.
Okay.
Like I use like the move tool to move up the edges and to fit the shape.
Great, great. I love that. It's a good way of working, right? To take a simple shape and then slice in extra detail and then move that extra detail where it needs to go. That's a great way of approaching it. Good job, okay? Here's a different way of thinking about things. Start simply, right? Because there is no make me a side frame button instead of Modo, so we're going to have to use basic shape, basic tools to kind of flush out and block out the overall shape, okay? Believe it or not, working in 2D is a whole lot easier than working in 3D. Kind of an odd thing to say, especially in a 3D modeling class, but allows us to create a good structure, a solid foundation that we can begin to extrude into that third dimension when we're at the right moment in time, okay? Let me show you a way of approaching this, and this is kind of the challenge, if you will, of 3D modeling, is that there's a dozen different ways to get us to that end result. Let's explore, a way of approaching this. So, on every project, okay, and I practice what I preach, okay, I'll show you here in a minute, maybe towards the end of class what I'm talking about specifically. We want to start blocking out our model. Paint with a broad brushstroke for as long as we can, okay? Because then we can go in and add detail as we go, okay? We don't want to start with a high-resolution mesh. We want to start with something that's relatively manageable. So what basic, simple shape is the side of our cannon here? What? Rectangle. It's a rectangle. You got it. So let's just start with the square tool, and we'll start flushing out our basic, simple shape, okay? All right, and to make it easier for you guys to see, I'm going to turn on the visibility of my verts. Okay, and I want to make them pretty big. Yeah, that way you guys can see exactly what I'm doing. Can you guys see the verts on my mesh now? These things in here? Yeah, all right, there we go. So let's just do some housekeeping real fast. And again, I'm just working with a two-dimensional plane, okay? Not, in every sense, not a three-dimensional cube yet. Because I want to be able to kind of start establishing the overall proportions of this shape pretty early on. And one of the things that I can see pretty quickly here is that there's actually an angle, okay, on the front of my frame. It's not a perfectly perpendicular plane change. So this vert over here, I'm just going to push back a little bit to begin establishing that change in plane, that little slope on the front. It's a good little detail. Good industrial design doesn't contain any perpendicular angles in it. We want to try to break those planes up as much as we can. It makes our objects almost instantaneously feel more three-dimensional, okay? How did you approach creating this wonderful stair step going down the back side of your frame? Yeah?
Again, with loop slice.
With loop slice, absolutely. Start slicing it in, and then what did you do?
Use edge
Use edge,
and the move tool.
and grab the edge, move it down, start moving it. I like it. That's a good way of working. Let me show you an alternate way of working, right? Because I want to get through this main construction phase as fast as I can, right? But I also need to ensure that I'm creating a solid structure that's all quad polygons and doesn't have any triangles or n-gons in there, okay? Triangles from time to time are okay, but we definitely want to strive to create quad polygons throughout the entirety of our mesh, okay? So let me show you another way of approaching this, because I'm all about trying to get to that end result quickly, okay? And believe it or not, the slice tool is going to help us out, okay? Now, I'm a big fan of the slice tool. Naturally, inside of our interface, you can find the slice tool inside of the mesh edit collection of tools, and there it is right there, the slice tool. Now, there's a couple of things in the slice tool that I like working, especially in orthographic views, because I can now draw out a line. It's hard to see on the projector, and for that I apologize. And shoot, it's even hard for me to see here. There we go. Maybe something right around in there. Yeah. You know what I'll do? I'm going to go back in time. I want to slice horizontally before I go any further. Let's do that. Slice. Something like that. Now I'm looking very, very carefully at that purple line to make sure that the angle that I'm slicing in, this one, is where I need it to be. And that matches pretty much perfectly the angle of that first little stair step. And I'm going to continue slicing horizontally across the mesh to get what I'm after. Okay, actually I missed one. Shift-C, slice again. I need to start dialing in that top. Okay, something like that. That's pretty good. So now I have an edge that defines the top, an edge that defines this first stair step. Let's continue this convention going down the rest of my scene. Okay. Now, one of the things that's kind of hard, especially when we're working with the slice tool, is managing that big purple line, right? Because that plane is like a laser. Anything that touches that purple line is going to be sliced. Oftentimes, especially when we're slicing big chunks of geometry as we have here, that purple plane becomes a barrier. Let me show you an option in the slice tool that almost instantaneously removes that barrier. Check it out. It's pretty cool. Now, of course, naturally, when we run the slice command and draw out that purple line, where that purple line resides in our three-dimensional interface, and you can see it really easily here, determines what is sliced. Whatever touches that purple line is going to be sliced. Okay? However, I want to get like all up in here and only slice and only kind of understand this line in here, this top of the stair step. Okay? I'm just going to go back in time a moment. Okay? So let me show you a really cool option inside of this slice command itself. And I think this is probably best visualized if I turn off my backdrop item for 1 second. Okay? Again, here's the standard function of the slice. Wherever the purple line is, that's what gets sliced. Okay? There's one other one that I just absolutely love. It's pretty fantastic. And I almost have it on by default because I love it so much. And it's the infinite option in the slice command. What this infinite option is going to do is extend that purple line infinitely along the angle that you established. Okay? Let me show you again. Here we go. So now, instead of drawing a line, oops. Hold on a sec. Infinite, I'm going to drop the tool. Something misfired. There we go. Now, it doesn't matter where that line is inside of my interface. See how it's slicing the mesh no matter where it is? It infinitely expands that plane on either end of the tool handles, which makes it very, very handy. The reason I use this a lot, is now I can get close, okay? Slice on the inside of something, and I get two great handles here, okay? Now I can very clearly see the begin and the end. I've established that slice angle on the mesh itself, and I zoom out, and the infinite option just continues slicing the rest of the mesh, okay? It allows me to work a little bit more directly inside the scene, and I for one, really enjoy it. It just makes working with the slice tool really, really easy. Of course, I can just fire it off, and I'm done. Okay. So there's all my slices at really kind of odd angles, but that's okay because we're going to chip away at this a little bit, okay? I've gone and established all the horizontal structural pieces I need for the side of my cannon, for the frame. Now let's just do the exact same thing. Again, I'm going to use the slice command. And I'll slice upwards. And I'm going to hold down the shift key to fire it off again. And after I slice horizontally and vertically here, I now have some pieces that I no longer need. I can take that, this entire top row I don't need anymore. All this stuff I don't need. And there it is. Okay? Quickly, I can slice the mesh up, establish the polygonal structure that I'm after to get what I'm after, all thanks to the slice tool and that infinite slice. Okay? Now this is a pretty good looking idea here. I like where we're going with this. Okay? This only took me a couple seconds to build. If you look at the object inside of 3D, I'm in the perspective view. Still just a two-dimensional shape. Okay? So there's going to come a point, at some point in the not too distant future, when this is going to be transformed into a three-dimensional shape, but I'm not quite ready for it yet because there's some additional detail in this area of the mesh that I need to ensure that I slice in to get what I'm after. Okay? Let's turn our backdrop item back on again. And again, once again, look at our image from the front. Okay? And specifically, I want to look at this little curve in here. That's a pretty defined radius. It's something that we can easily see in the reference. It's a feature of the actual object itself, so we should look to, as much as we can, to create this with geometry, to physically define that radius with some polygons, okay? Now, I'm working in 2D. Is there any way that I can easily go in and create that curve? Vertex beveling. Yeah, absolutely. Check it out. And this is a great application of the vertex beveling tool set. Let me show you how it looks. Of course, naturally, I'm going to grab the vertex. What's the keyboard shortcut for beveling? B. You got it. And now I'm going to left click and drag. And I can pull out a nice radius. Okay? Now, please note that I'm on a round level of 2, and I did that very intentionally. Let me show you why. The round level of 2 gives me a nice polygonal structure for this radius. If you take a step back and look at it, at a round level of 2, what I've established is a start, an end, and then a middle point. Wait, excuse me. Start, and, was I on round level of 2? We should have a middle point here. I was on round level of 2. Yeah, I'm just going crazy and I was looking at the wrong thing. Because here's the start, here's the end, and there's the middle point. Sorry, I selected the wrong one down over there. My bad. I apologize. Okay. Round level of 2 just gives us that middle point on that arc, and that's a good practice to be in. Okay. However, we have a tremendous problem on our hands. On one side of the fence, mission accomplished, right? We've kind of gone in and added a tremendous amount of detail. Excuse me, hit the wrong button. I've gone in and I've added a tremendous amount of detail in that area, which defines a feature of the mesh geometrically. But what have I accidentally created? A whole series of n-gons, right? Actually, there's just one, a gigantic one. Go back to the earlier part in the semester. What is an n-gon? Oh, I should be giving a test on this right now, right? Okay, so in the surface world, we have 3 types of surfaces, right? We have a triangle, which is a surface with how many verts? 3. We have a quad polygon, which has how many? 4. So what is an n-gon? There it is, anything higher than 4, okay? Now, we don't want n-gons, okay? They are technically supported by Modo, but not all apps in our 3D universe support n-gons. Game engines certainly don't. It's important for us as 3D modelers to always be constructing our meshes in a fashion that allows them to be sent to another app. We want that interoperability. It's a feature of our mesh, and that makes you a good 3D modeler if you can do this. 3D modeling is really nothing more than death by 10,000 razor blade cuts, right? It's a whole bunch of little micro problems that we got to figure out and troubleshoot. And this is a really great example of it, okay? 3D modeling forces you to be a problem solver, okay? I, have created a problem, and hopefully the projector will choose to come back on here in a minute. It'd be very difficult to do the rest of the class if the projector doesn't come back on. There we go. Okay, here we go. All right. So we have a problem up here at the top of my mesh. Okay. I've created an n-gon, and specifically, if you look at it, I got 1, 2, 3, 4, 5, 6, 7, 8 verts associated with one surface type. This is a no-go. I have to slice this into something that gives me all quad polygons. Okay. We don't want to leave this gigantic n-gon inside of my 3D scene, so we got to make some changes. We got to do some editing. Now, how could I do this? How could I do this quickly? We can't delete the verts because then that will delete. Yeah, it'll collapse that entire structure. We're going to add edges. Absolutely. So we got to slice some additional detail in here, right? Now, there's a couple different ways that we can go about doing this, but let me show you a great alternative, one that you'll find a lot of folks choosing to use. It's a fantastic tool that's almost purpose-built for moments like this, okay? It's called edge slice. Now, the purpose of the edge slice tool is to slice from an existing edge to an additional existing edge. So we have to have two edges, and the computer's going to connect those two edges with a new line, okay? You can find the edge slice command, of course, naturally inside of your mesh edit collection of tools. It's got a keyboard shortcut next to it, so instinctually you should know that this is an important tool, right? Check out how it works. It's pretty neat. If we fire off the edge slice tool and return to my mesh, I'm going to put my cursor in the middle. If you notice pretty directly here, I get a rollover highlight, okay? That's the computer is telling us, hey, this is the edge that I'm going to start my slice from. Okay? If I left click on the edge, I get a little yellow dot. And I'm all zoomed in, so it's going crazy. All right? And I can move that little yellow dot anywhere I want along just that edge. Now, whenever it reaches a vert directly above or below, it's going to stop. So it's only going to slice in between that edge, which is what we want. In actuality, really what we want is that we want to slice from an existing vert. Okay? I don't want to go in the middle of the edge. I want to start at this vert. Now, I'm going to go over here. So we're going edge to edge. Okay? Now, I'm just kind of eyeballing it here. I want to make sure that the line that I'm creating is roughly parallel to the edge immediately below it. So I'm just trying to evenly spread out and distribute these edges across the entirety of that surface. I'm going to hold down the Shift key real fast and reactivate the edge slice command. And once again, this is how it works. We start in an existing edge and then drag up. I'm zoomed in, so it's freaking out. Sorry. Drag up or down and then go to an edge on the opposite side. And I'm going to continue this idea on the next one. Now, a mistake that a lot of folks make, and I got shuffled into this category pretty early on in my career, is that I would keep slicing going all the way up all the way up this part of my mesh, right? And I'd go here, and I'd slice over there, trying to make it parallel as much as I can. And all of a sudden, we have a really super thin polygon up there at the top. The computer doesn't like small, thin polygons, okay? We want to try to make them as big as we can. That's not to say that our meshes need to be as low resolution, but we don't want to have a lot of big polygons like we have down below, neighbored, to some smaller ones. Especially we go medium, teeny tiny. The computer's not going to like that, especially when we hit the tab key and begin to subdivide this entire mesh. You're going to get a weird, wacky result pretty instantaneously. So here's an alternative. Instead of slicing across for that last one, okay, I'm going to hit undo, get rid of that slice. There we go. Instead of going from, east to west along that edge, what if I slice vertically? And I go north to south along that object, okay? I'm not going to start here. I'm going to start there and go down. Now, if you look at it, I have a quad polygon there, and life's happy. However, what have I just now infused? another end gun right below it, right? Because this surface here has 1, 2, 3, 4, 5. How can I resolve the end gun that's immediately below it? Go all the way down. Slice vertically throughout the entirety of the mesh, okay? So with edge slice, we have to keep going all the way down like this. Now, if you have a lot of edges in there, and if you're an OCD control freak like I am, this really starts to turn into a big-time problem for us, okay? Because pretty easily you can see that they're not all straight, and I really like that they're straight. So let me show you a great option for edge slice that will actually save you a bunch of time and give you the accuracy that you need. I got edge slice active, multi-slice. Okay, multi-slice is pretty rad because what this allows us to do is once again get the same edge slice functionality that we had before, but this time we get this cool little dotted tail that goes underneath our cursor. And what this allows me to do is slice all the way down to the bottom. It's going to notice every single edge that it comes in contact with, that tail, and it's going to slice along that dotted line. It allows you to slice through everything, which is pretty cool. And now if we take a look at the mesh that we've created here, yeah, this is looking pretty great. And we've got nothing but quad polygons across the entirety of our surface, and that's exactly what I'm after. Okay? Pretty cool, huh? Pretty neat. Now there's one other thing that, one other feature that we need to add in here, and I'm not going to go through all of this, but of course this curve needs to be sliced in as well. When you're working with geometry like this, we don't necessarily need to add more geometry. We can use the existing geometry that's there, right? For example, if I wanted to start to make some changes here, what if I put that edge to define the corner? Now I think having that one over here is probably a little too much to handle. So let me just slice in some new geo here. That works, okay? And I'm also going to slice in some new geo in here, and I need one more because I got 1, 2, 3, 4, 5. Yeah, actually this is fine because I can make this the middle point. I was just trying to figure out the middle point of my arc right around there. Here it is, okay? So I didn't have to add a tremendous amount of new geometry to establish that bottom curve over here, right? I just used the existing geometry that wasn't doing anything geometrically to define the shape to create that curve for me, okay? Pretty cool, huh? Pretty cool. Now, because I'm crazy, I also do things like this and start to kind of space things out. I like angles. I like to make everything nice and soft and smooth because that's just me, and I'm crazy, and I'm OCD about it. Like I said, I'm both the right person and the wrong person to be doing 3D modeling because I get really kind of particular about all of my wireframes, and I want to make sure that this is driving me crazy right now. I gotta fix this. Like some of this stuff, I want to go in and just really make sure it's nice and straight. But that's just me because I'm weird and wonderful. I am a unique snowflake. Let's just put it that way. Okay, I gotta stop. I'm being too much of a 3D modeler now. Okay, that's good. That's good. All right. So I'm happy with it. This is a good shape. This is a good foundation for the next step. If I wasn't teaching, this would have taken me about 2 minutes to establish quickly with slice and edge slice. It allows us to construct very quickly, okay? Paired with the reference, the backdrop items, this becomes a really simple part of the mesh to create, okay? Now, at this stage in my own production pipeline, I am ready to start bringing this out into 3D. So I'm just going to simply extrude this shape out, okay? And life is good. I want to turn down my points. There we go. Now, what's going to happen when I hit the tab key? I'm going to subdivide this mesh. All hell is going to break loose, right? And this is the moment where a lot of us begin to panic because the entire envelope of our mesh collapses and starts to be pulled under the tension of the algorithm, right? So in order for me to retain the shape, okay, what do I need to add? Yes, and specifically edge loops, right? Where? Yeah, on the corners, okay? Now, the big benefit of working with sub-Ds is that we can preserve the initial shape, but we've got to add some new edges in there to shore up the entire thing. Now, I'm only going to do this front side, so it's going to look a little strange, but that's okay. Naturally, if I was actually working on this mesh, I'd go through and do the other side at the same time, but just for brevity's sake, sometimes watching 3D modeling is like watching paint dry. There's the plane that I want to lock up, okay? Because I always think of these as plane changes, right? We're going from this plane on the top to these over here on the side, right? So whenever I have a plane change that I need to kind of lock up and tighten under the sub-D algorithm kind of properties, I need to add new edge loops, right? To make that edge loop sandwich. Remember that from last week? So I got the edges that establish the plane change, and then I add one above and one below. Something like that. Now, let's do an inspection here. We can't go too crazy with this, especially up top. If we continue adding some value here, uh-oh, wonk, that's bad news bears, right? That's, see how that vert, pay attention to this edge segment right here, right? Yoink. So we can't just gonna do whatever we want. We have to pay attention to how the tool is adding edges into the interior of our mesh, right? But something, in all honesty, something like that is pretty powerful. Uh-oh. Ba-ba-ba-bum. Wah-wah. Problem, right? You fix one thing, you break another, right? This is now a problem for me, okay? A, why is it a problem? Why is this something that demands my attention and requires future edits to the mesh? Not so much that there's too many edges, but what has it produced?
Together.
Yeah, they're kind of together. They're actually all, they're compliant surface types. But what about this polygon, this surface right here?
Too many verts.
Too many verts. What's it called? N-gon. And we know like the N-gons, right? We need to continue slicing up this shape to remove this N-gon, okay? And it all starts with this corner, because this surface over here, these are just two triangles, okay? That's fine. I can deal with two triangles, but a gigantic N-gon over here, bad. I got to get rid of that, okay? If I had aspirations of sending this to a game engine or sending this over to ZBrush or a Mudbox to continue sculpting on it, this N-gon is a gigantic barrier for that next step. In 3D modeling, what we produce influences what we're able to do next, right? Because the entire foundation of the production pipeline is built off of our geometry, okay? If my articulators and my riggers would come back to me and say, Pat, get rid of that N-gon, this is not going to animate. My animators would start complaining because it's not going to deform the way it needs to be because of that N-gon. My rendering wranglers, okay, my lighting technicians can come back to me and say, Pat, this surface isn't being lit correctly because of that N-gon, right? We want to try as much as we can to remove these N-gons, okay? So how do we do it? Well, we're going to slice up some geometry. From our previous exercise in slicing, we sent this edge right here down south. We sliced it vertically, going down. Now, I'm going to do the exact same thing. I think that's a good place to begin. So let's look at it from an orthographic view. Excuse me. Once again, I'll power out my slice command. I got my multi-slice going. Now, one of the things that is kind of cool, and one of the things that we should be very active in producing is even topology. Now, if I was to do this, okay, a lot of you guys are saying, Pat, sweet, mission accomplished, right? But watch what happens when I subdivide this. it starts to pull right here. You can actually see the shape pulling. It's beginning to go to a point, okay? When we're defining curved surfaces, and excuse me while I turn my wireframes back on, when we're defining a curved surface, we want all the points that establish that curve as evenly distributed along the curve as we possibly can. When we have bunches of points like this, right here, see this little cluster? When all four of those are together, it's going to decrease the influence of the algorithm, and it's going to pull everything. It's going to make a point, a sharp edge, which is not what we want on a part of the model that's supposed to have a big sweeping kind of arc to it, okay? So I need to make a change to this, okay? And actually, I'm going to change the entire structure of this part of my mesh. Welcome to creative problem solving, right? We fix one thing, we break another, and then we got to fix that, which breaks another, which we got to fix that, okay? This is just kind of the world that we live in, okay? However, we can make some intelligent changes to the mesh to get what we're after, right? With the idea that we're just trying to evenly space out all of these points, okay? What if we go in and try to basically repurpose, if you will, these points here? I'm going to make these the new center point of my arc, okay? And I'll slice in an additional edge here to make it a nice even number of verts defining that arc, okay? I think once you'll see it, you'll go, oh, I got it, okay? All right. So here's what I'm going to do. I'm going to go back in time a couple steps to get rid of that oops, that boo-boo. All right. Let's see. So I'm going to do some counting now. 1, 2, 3, 4, 5. I like to go to odd, so an odd number to define that arc. Okay. So I need to add 2 more. Well, we're going to get 1 for free when we slice down vertically from my little miter joint here. Here's another great thing about working with edge slice. If you hold the control key down while you click on these edges, it places the new slice in the center of the edge that you're slicing. Okay? I like that. That's pretty cool. Now I need another one up here. Let's turn on multi-slice for this. We're just going all the way straight down. And now I have 7 dots. 1, 2, 3, 4, 5, 6, 7 to define that arc. That's good, okay? Where's the middle point? So 1, 2, 3. So that's the middle point. Let's turn on our backdrop item. And I'm going to start moving these things around. And FYI, I'm going to do this in my edge selection mode. Middle mouse key here. Just so I'm grabbing everything in that zone that's responsible for creating the shape. And now what I'm doing is I'm just trying to evenly space out all these edges according to reference. Paying a lot of attention to their placement. Something like that. That makes me a happy camper. I like that very much, okay? And now the inner geek in me is also saying, Pat, you really got to fix this thing. And I'll be honest, this is how exactly I would do it. Multi-slice saves my bacon because now I can just connect the dots. Whew, that makes me happy. I'm going to do the same thing over here. Now that I have a really good laser focused idea of where the beginning and the end is, that makes me happy. I like that. Okay? I like nice straight lines. It defines the purpose of those edges quite wonderfully. All right, now what's going on here? Oh, I don't have a pair on the back side, but that's okay. I'm just doing the front for right now. There we go. Actually, that caused more problems than it should have, but that's okay. Here, actually, now that I have a much better understanding of what this is, believe it or not, I'm going to delete a good half of my model. Oops, I grabbed the wrong one. Yeah, sometimes it's good to work in 2D as long as you can, but it would have been more difficult for me to slice and get everything kind of connected together correctly with that extrusion off the back. Now I'm going to do the same thing that I just did. There we go, along the front. And now we've removed, and I can even get rid of that miter if I like. Now I've removed, that n-gon. Okay? This is the type of thinking that we have to go through to ensure that the models that we're creating are compliant. They're all quad polygon and will continue to work efficiently in the larger context of the production pipeline. Yesterday during GCOM 402, the morning section of this class, I was asked, Pat, how did you know how to do all this? And I said, easily, experience. Okay? You have to fail at this for a long, long time and really hit that tab key and understand what the algorithm's going to do to get a really good, solid understanding of how you need to structure your mesh. Okay? The big takeaways, though, and this is some of my experience hopefully being projected onto you, quad polygons. Okay? Quad polygons, quad polygons, quad polygons. Okay? If your entire mesh is structured with quad polygons initially, you're building your house on stone. Okay? That's a good, solid foundation. With a lot of those little micro bugs fixed inside the mesh, once again, I can extrude the mesh into 3D, and let's examine pretty quickly here. There it is, looking good. I'm going to do a little loop slicing down this center band. I'm going to do a count of 2, a mode of symmetry, so I do both sides at the exact same time. Yeah. Hit the tab key now. Yeah, we're getting there. I still have some things I need to fix on this side. But if you look at the structure here, boy, that is just locked in, right? Look at that nice radius. If I was to turn off the visibility of my wireframes, sometimes your wireframes kind of occlude and change your understanding of what you've created. With the wireframes off, this is looking good. Okay? I can easily sharpen the corners for the remainder of my mesh just by going in and adding additional edge loops along very specific places. Okay? Now, I would probably choose to go in, oops, I have miters all over the place here, so I got a lot of work I got to do. This is not quite ready for prime time yet, but at the very least, I'm stepping forward in the right direction. Okay? This is the type of thinking that we have to go through in order to get a really, really, really good high-quality result. Okay? And luckily for us, it doesn't take too much energy. On a model like this, it's pretty fast and pretty easy to create the results that we're after. Yep. Yeah, there's some fun things in here. Now, if I wanted, I'm just going to jump to the tail here because it's just an easy place to explore this next idea. Now, these miters down here at the back, this little loop is exactly what I want, right? This allows the sub-D algorithm to do its thing. It shores up the shape, but structurally, I've produced a whole series of n-gons right in here that I need to resolve. Okay. Now, this bottom one gives us an excellent, excellent opportunity to talk about what we need to add in an easy area of the mesh. Okay. We all know from experience that I need to slice like this, going that way. Okay. Then also slicing up here like that. That's what we need because it gets rid of that miter pretty quickly. However, this is now a three-dimensional shape. Okay? Three-dimensional shape. I need to do the backside, or I would like to do the backside at the exact same time. Right? Is there a tool that allows us to do this quickly, to do the front side and the back side simultaneously? I'm sorry, say it again? Loop, not so much. Okay, because loop slice is would be a little bit difficult to use in this particular situation. Here's a good one. Okay, what about just traditional slice? Okay, what if, because I want to slice, let's see, I want to slice all of these going across the front and all of these going around the back side. I want to slice those together as a unit. Okay. Now, I've selected a whole series of polygons. I'm telling the computer with the selection, only slice these, okay? With a selection in mind here, the slice tool will do a really great job of getting me what I'm after, and I don't have to worry about it accidentally slicing something else because I've filtered my scene with a selection. So if I run slice, this is what I'm getting here. That's cool. I got the infinite option on, which is pretty fantastic. Okay. However, let's see. I'm just looking at what I got going on. Yep, that looks good. However, when I sliced, I accidentally sliced in a second vert. Okay? Problem, right? When I started that slice operation, it didn't begin its slice precisely on the vert that defines the corner of that miter, right? Problem. Okay? Problem that we can fix with our snapping engine. Okay? Our snapping engine is pretty neat. We're going to talk in detail about the snapping tools going forward in the future, but it's something that's so important and so critical and such a large part of our 3D modeling workflow. I want to talk about it today. At the very least, start introducing it today. I don't think it's next week. I'm trying to think ahead. It's either next week or the week after. We're going to be working on a house. We're going to be doing some architectural modeling. Okay, and so as one might imagine, the snapping tools are going to be really cleanly defined in that area. Let's get going though. It's really, really easy. I'm going to hit undo to get rid of that slice. There we go. And you can find all of your snapping tools up here at the top of your interface. It's this button. Now the snapping system is a global snapping system. That means it's literally going to influence every single tool that we have active going forward. So we've got to be mindful of this, right? It's on or it's off. So we don't enable like snapping on a per tool situation. We just turn it on and every tool is going to be influenced by the snap parameters, okay? We can turn our snapping system on by hitting that button. You'll know that the snap system is enabled because the button will go gold, which is kind of the Modo convention is saying active, right? So it's on or it's off, okay? If you want to change what you're snapping to, hold down the Option key on your keyboard, all right? And you'll expose all of your snap options, okay? This little popover shows you what you're able to snap to inside of Modo. And this is neat. This is one of the reasons why I love Modo so much, because look at all the different component pieces that we can snap to. We can, of course, snap to verts or points. Everything can do that. But we can snap to edge centers, polygon centers. This is, now we're talking, right? This really is a powerful tool set, and I personally love, 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 love the snap system. It's pretty great. I'm going to leave it to vertex snapping. I'll dismiss the form by clicking off of it. And now watch what happens when I use my sliced commands, okay? It's kind of hard to see, and I apologize because it's small. But you see the little highlight? That little rollover highlight there, that's the snap system saying, hey, this is what you're about to snap to, okay? So you're always going to get a preview of the element that's going to be snapped to or from. So there we go. And I want to snap to that corner. And now I don't have to be super close to my model, okay? A little too far away. Snapping from there, and it even snaps to right angles, which is pretty great. I'm not holding down the control key. I know it may be a little hard to see, but I just snapped to a perfect, perfect straight line. In addition, what I don't get here are two verts. Well, it looks like I did in this particular situation. It's making a liar out of me. But they're not right on top of each other, and it's perfectly straight. Oh, wait. Oh, you know what I was doing? I was selecting the vert on the back side of the mesh. There is, in fact, only one vert there. Yeah. So it worked. Yeah. It's a great way to remove those double verts. If you snap to them, you're not going to get doubles because they're going to get joined when the tool is active. That's pretty cool. I like that. I like that very much, actually. Okay. And it makes slicing stuff in really easy. And I did the back side and the front side at the same time. I always do a spot check, make sure life is happy. Now, do I have a double over here? I do. Where's my double? 1, 2, 3. Oh, I just can't count. That's 5. Yep, that's good. Cool. Do it one more time. This time I'm going to slice going down this direction. And I'm filtering the influence of the slice tool with the selection. And then with the snap system, come on now. Oops. Let's go back in time. That didn't work clearly. This is where that angle snap kind of gets in the way. One of the cool things that I like about the snapping system is that you can start a tool with it on, and then you can turn it off and get what you're after, which is right there. Aha, wonderful. with those miters removed, now I can very simply do a loop slice here. Add some additional edges to shore up that intersection, and you can start to see when I hit the tab key that life is good. Okay? That I'm beginning to lock in that whole part of my mesh. I do the same thing for up here at the top edge of that stair step to get what I'm after. Okay? Pretty cool, huh? Welcome to 3D modeling. Okay? There's a lot that goes into it. It's a one gigantic, problem-solving solution. Cool, huh? Hopefully over the next couple of weeks, you'll begin to establish your own sequence, your own thinking behind putting all of these meshes together. As 3D modelers, we're often kind of expected to be like good chess players, to think 8 or 9 steps ahead, because what we do here on step 1 allows us to do something really kind of amazing on step 9 or step 10. Our models kind of are built on top of the previous step, okay? So we want to make sure that we're giving ourselves the best opportunity to make something neat going forward. All right, questions on these ideas? Cool. Let's jump in and start looking at what we're going to be doing for our lab assignment, because we actually have 2 lab assignments that we're going to do today. We're going to be kind of piggybacking off of the idea that we began last week by doing the goblets and glasses lab assignment. You go over to the week 8 section on Canvas, you'll find these modules already established. We don't want Star Wars anymore. Goodbye, Star Wars trailer. We'll see you later. I love you so much. Oop. Apparently our city website is not going to work. Here, well, oh, here we go. Great. So if you go into the e-learning section, of course, naturally, if you go into Canvas, you'll find the week 8 module. Oh my gosh. Our internet's so slow today. Ugh. All right. I've grown impatient with it. I've already downloaded them to my machine, so let me just show you what they look like. Your job this week in your first lab assignment is to take these 2 profiles that I've given you and create an entire model from them. However, so this is a little bit like we've gone over this before. Think of the medicine bottle last week, right? We used our traditional box modeling technique. We started with the cylinder, beveled it up, hit the tab key, added some edges so everything got smoothed out. Okay, everyone did a really great job on that. Well, we're going to build upon this idea again this week. Okay, however, we're going to change the game ever so slightly. Instead of relying on our traditional box modeling technique to create these profiles, we're going to create some curves. And then we're going to do what's called a radial sweep with those curves, right? As I mentioned just a minute ago, it's a whole lot easier to work in 2D than it is to work in 3D, okay? So let's use some 2-dimensional tools that we can use in a 3-dimensional fashion, okay? Let me show you how they work. They're pretty neat. There is a sequence that we have to honor and follow in here. Let me create a new mesh item, get rid of that other one. Okay. I'm going to turn my grid on because the grid plays a very important role. Okay. All right, now I can understand pretty directly, just thanks to the not awesomeness of our projector, how difficult it is to see these big black lines, right? But those big black lines in the grid represent what? What's that? The intersection of those black lines is what? Oh, you should be happy. I'm not giving you guys a test today. It's the origin, right? It's the center of our universe. And this origin is a critical modeling feature, okay? Especially when doing radial sweeps and radial duplication, which we'll talk about in the context of our homework this week, okay? So here's what we're going to do. The big picture idea is that we're going to create a curve very similar to how we would create a curve over in like Photoshop Illustrator, in Adobe Illustrator or Adobe Photoshop, okay? And then we're going to take that curve and basically do what's called a sweep. We're going to revolve it around the origin of our scene and create polygons, cylindrical polygons from that profile, okay? In other applications, this is called like a lathe. It's very similar in function, but it all begins with a curve. Now, inside of our basic toolbar, the developers down at the Foundry have given us a whole bunch of curve types right here. Now, yours may be looking like that. That's the pen tool. We are not working with the pen tool today, okay? Important concept. In Illustrator or in Photoshop, it's called the pen tool. But here in Modo, it's called the Bezier curve tool. So the one that we're looking for is this, Bezier curve. We'll talk about what is commonly referred to as the Hermite curve and the B-spline curve a little bit later on in the semester. But let's start off with the Bezier curve type. Okay? Now the Bezier curve type works in function almost identically to the way that the pen tool works over in Photoshop or in Illustrator. We lay down control points by left-clicking in the scene. And if we left-click and drag, well, actually they're created on everyone, but we get these lovely tangent handles that we now can affect the totality of our curve. Okay? You don't have to break them. In Modo, they're already broken. However, if you do want to control both of the tangent handles simultaneously, hold down the Shift key, and it will unify the tangent handles, and they'll move together as a unit. There they go. Dun, da, da, da. Awesome. Now, with this tool, be very mindful. Be very mindful of those little blue cubes along the path itself. These are the control points. Notice that there's one always gold or yellow on your screen. That's the active control point inside the scene, okay? That means that this gold one is the one that you're currently editing and working on. However, I bring this to your attention because all new points, while the curve tool is still active, is going to be created from that gold one, okay? So check it out. If I was to select the control point at the end, bloop, right there, okay, now that one's selected. A new control point will be created after it, up there, okay? If I was to select this guy over here while the curve tool is still active, check it out. See how I'm adding new points after, okay? That's a rule of the tool, okay? Now, if I drop the tool, hit the space bar, my ability to add additional control points to this curve is completely eliminated. And I want you to remember that, okay? That you're only able to create points along a single curve point, initially. Once you drop the tool, you can only edit the location of those existing points. So I can't go back in right now and add more points. Okay, I'm all zoomed in, so it's freaking out. See, I can only edit them. I can't add them. I click over here and nothing happens. Okay? So we got to be careful. Let's get rid of that curve. And I'm going to create another one. So we got to be a little bit careful. Okay? We want to make sure that we have a whole series of control points that give us the illusion that we're after. Now, one of the most important things that we need to establish when it comes to curves, especially in the lens of doing a radial sweep, is that this needs to be a closed, in finger quotes, a closed curve. Point being that we need to have a white line go from the last control point down to our first one. Okay? Our tool properties will give us this result. If you go back over to your left and examine the curve tool properties, we have a choice here called closed. And we click on it, boop, it does the hard work for us. Okay? That's the only way to make a closed curve. This is not like Illustrator where you can hover your cursor over the first one, you get a little circle next to the cursor icon, and it connects it for us. That's not what this is, right? In the Modo world, we physically have to go in and say closed. Okay? Now, what are we going to do with this closed curve? Well, we're going to use it to define the overall shape. Okay? Now, there's some rules in here that we need to follow because what we've created is a profile. So we've created half of what this object is going to look like, much like we did with our medicine bottle, right? And you're going to do it twice for our lab assignment here in a second. Okay? But there's some rules in here that we need to follow, and this is very, very important. Okay? If you miss this part of your sequence, you're going to get some weird tornadoes on your inside. You're going to have a black hole. It's going to be strange. It's just not going to work, okay? So remember this part of the sequence because this is the most important part. This determines your success with the radial sweep. We need to do some alignment of all of the control points of this curve inside a 3D space. The first place we begin is the border, okay? These control points, okay? And, oh, this came up yesterday. Good question. After I create the control points, can I move them around? Yep, this is still live. Now it's freaking out because I'm all zoomed in. But these are still live points. I can even change the location of the tangent handles. So you still get a lot of control. But those two control points, okay, the two control points or the three or however many control points defined the border, the center part of your profile, they need to be centered along the x-axis, okay? Not only do they need to be centered, but they need to both be precisely on the x-axis. And I'm going to change it. A lot of folks, they would just grab them both and just do center selected along the x. And that's all well and good. But did it put both of those verts right here in the middle of the x-axis? No, it looked at them as a group. I'm sorry, here's the x-axis here. It looked at them as a group, and it centered the group along the x-axis. We don't want that. We want each individual point to be precisely placed at the middle of the x-axis. So for us, the tool that we want to use is not center selected. If we go to our vertex collection of tools, set position is going to do the job that we're after. Okay? Set position is going to tell the computer to put each vert individually, independent from the rest, at a very defined location inside the scene. If you activate the tool, you'll get a cool little popover. And what this popover is saying, and what it's asking you is, where do you want me to put each vert? At a value of 0 along the x-axis, where are we placing these verts? Origin. The origin, okay? So this is not, even though it says 0 feet, this is not a dimension, this is a location, okay? So we're putting this at 0, 0, 0 inside of our three-dimensional space. So I'll leave it at 0 along the x-axis. Watch what happens to my two little verts when I hit OK. Bloop. They get individually and independently placed along the right, the correct location. That's critical. Critical, critical, critical. That's step 1. Step 2, okay? Step 2. We grab all the verts that are responsible for defining this curve. Okay, marquee selection, grab them all. And once again, we're going to go to set position. But this time, we need to make sure that the entire curve is positioned along the z-axis, at the center of the z-axis, okay? So the two that represent the boundary, the border, centered along the x. Everything centered along the z, okay? So I'm going to leave my value set to 0, but change my axis to x, or excuse me, change my axis to z. Now nothing changed, that's good, that means they're probably already where I needed them to be. If you look at it in perspective, there it is. Looking good. Let me turn my grid on, I apologize. There it is. Yeah, excellent, that's what we're after. That's what I'm after. Okay, so step number 1 was to align the border verts along the x-axis, as I've done here. Step number 2 is to set all of the verts along the z-axis as value 0. Step number 3 is to tell the tool handles to fire off and evaluate their kind of sequence at the origin of the scene. You see how the origin is kind of becoming the common denominator in this thought? If the boundary and the entire blade, the curve, is positioned at the origin, and we tell all the tools to look at the origin, we're going to get the correct reproduction of the shape that we're after. Okay? So I'm going to change my action center to origin. You can find your action center pulled on menu at the top of the screen. There it is, origin. Every tool is now going to evaluate at the origin, which is what we want, because we want the radial sweep command to start its whole thing at the origin of our scene. Okay, so we can find the radial sweep command right here under the duplicate menu. Now I forgot to select my curve. Got to do that. Select your curve. Radial sweep is the first one, the first tool inside, right here, inside of our duplicate tools. And all that we need to do, since we have changed the action center to origin, simply left click. And now I have this weird bowl looking thing. I don't know what this is, right? But this is the result that we're after, right? It's taken that curve and it's kind of, swept it around 360 degrees, and wherever that curve goes inside of that circle, it's going to create polygons for us, okay? Now the product of this, point being, if you get a really weird result like that, that's kind of abstract, by the way. That's kind of cool. Or like this. That's not right. We want to do it along the y-axis, and I get my weird bowl thing. There we go. One other thing, sometimes, depending on how you've drawn your curve, you'll have to invert your polygons. If they look like this, okay, if everything looks backwards, just enable invert polygons in your radial sweep tool properties, and you'll get what you're after. I'm going to drop the tool, and let's take a look at what we're left with. So what we get here are just raw polygons now. So if we need to edit it, if we want to do some beveling, some material properties, anything we want, we now have traditional polygons like we've been working with the entire semester. I can see some bugs in here that I want to change, some things that I need to go in and fix, okay? Specifically, I got some thin edges that are right next to each other. Check this out. I don't need both of those in there. I'm going to get rid of that one. See? Just regular edges. Nothing magical about it. We're free to go in and fix any problem that we see. That's weird. Actually, there's a whole... Oh, look at that. That's fun, isn't it? Let's get rid of all that jazz. Delete. I'll select the edges here, hit the P key to fill the hole, and I've solved that problem. Actually, that's a very tiny polygon. Delete all of that. Do the same thing. I think I have the same problem down here at the bottom. Yeah, I don't know what's going on here, so here's my solution. Since it's a flat planar shape, let's just delete all of it and then fill it real fast. Whoop, problem solved, okay? So your mission for your lab this week is to take this idea and apply it to creating both the goblet and the wine glass, okay? Doesn't matter to me where or how you do this. If you want to do, I guess it does matter, but let me quantify my statement there. If you wanted to put each object in their own project file, I'm happy with that. So a project file for the wine glass and another one for the goblet, I'm cool with that. Or if you want to do both in one project file, I'm good with that too. Either way, it doesn't make a difference to me. Just figure it out. It's up to you, okay? In addition to making the model, you're also going to be making a render, okay? So when you're done making the model, using the techniques that we've shown here in class, do some rendering on it, okay? Try to make it look like a wine glass or a goblet. I'll leave it up to you and your creativity as to what that looks like. Sound good? Everyone confident in what we're doing? So and we can knock this out here pretty quickly. It's not going to take as long as you think it's going to take, okay? Because if you think about it, a majority of the work is just making that curve, and then doing the sweep is pretty fast, okay? Should we get to work? All right. Oh, one thing. If you need a little bit of a refresher, if I'm helping someone and you're stuck on the process of working with the radial sweep, it is, in fact, in Canvas. I have a dedicated video on it. Here we go. It is under week 7, radial sweep, right there. So if you want to go back and get a small little refresher as to the sequence, the radial sweep command is going to do the job. Yes, sir.
Where do you find these videos exactly?
So it's in the week 7 module. So go to modules. All right, let's get to work. So one of the things we're going to do today, one of the things. Yeah, it's not all we're going to do. We have to talk about the Lego brick and our homework tonight as well. No. All right, so the second part of our lab today, and it looks like you guys are almost done finishing your gob and your glass. So if you haven't finished yet, that's fine. Just finish the rest during the lab time. As a reminder, you should be spending about an hour and a half every week on your lab assignments outside of class. So if you don't finish in class today, that's by design. I'm only giving you about half the lab time that you're expected to get. Okay. The second part of your lab assignment is another great little project for us. We're going to be making a Lego brick. But how we make this Lego brick is going to be fundamentally different than how we've created things before. Let's just travel back over to the assignment sheet real fast inside of Canvas and take a look-see as what the expectation is. Because when you really analyze and dig deep into the actual Lego brick itself, here we go. This is what we're after, okay? Check out the image here real fast. This is a good representation of what we're going for. Geometrically, we have a square down here at the bottom, but then we need to transition over into a circle, okay? Very noticeably, we can see that little radius that transition creates for us, right? Now that's a big feature of a Lego brick, is that little connection point between these two very unique and different shapes. We should define that with polygons, right? We need to physically connect a square to a circle. Well, how do we do that geometrically? Retaining all quad polygons, good flow across the surface, and good clean geometry that's going to subdivide correctly. Because if you look very carefully here, what don't you see? Polygons. That means this is a subdivided mesh. We want to take advantage of the algorithm. We want to take advantage of hitting that tab key so it smooths out the polygons going around the outside of our little Lego pegs. Okay? Point being, we're not just creating a cylinder and sticking it in a cube. We're actually physically connecting them, welding the joints together and creating what's called a contiguous piece, right? Where all the polygons are connected to each other. This is a bread and butter technique for us in 3D modeling. We're often going to be creating multiple separate pieces and then combining them so that we can produce those little transition points, okay? It's an old school idea. We've been doing this for many, many, many years. Let's look at the technique and start understanding how we start connecting all these pieces together. Now, I've pre-cooked some stuff that will help visualize this process a little bit. Before we get started in that pre-cooked area, though, I want to start in, not here. Let's get rid of this. And I want to spend just a brief moment talking about circles, okay? Believe it or not, circles, right? And I want to make them all the same size, 7 feet by 7 foot. Go. I'm actually going to make 3 of them. Turn on the visibility of my my verts so you guys can see them. Nice big ones. There we go. So there's one. That's an 8-sided cylinder. Let's do the exact same thing again. 7 foot. 7 foot. But this time, I'll make this a 10-sided cylinder. Of course, lastly, I'll make a 12-sided one. It's also the same dimensions, and I'm kind of getting nerdy here because I can. All right, let's look at let's look at all 3 of these circles and start comparing and contrasting the differences between them, okay? Now, looking at the structure of the circles that you see on screen here, and most importantly, the vertices that are associated with each one of these circles, what's the common element between some of them, okay? Structurally, they are different from one another, but there are some similarities between 2 of them. What about the edges? Yes, they have them. Different amounts. So as a reminder, this is the 8-sided circle, 10, excuse me, and then 12. Okay? 8, 10, 12. All 3 of them have a common element. Okay? Look very carefully at how the verts are positioned around the circumference of the circle.
There's always one at the top bottom.
Bingo, absolutely. Arthur hit it right on the head. Absolutely. There's always going to be a north, south, north, south, north, south. Okay? If we continue that pattern and examine how they're similar and different from one another, check it out. Here on the 8-sided, we have north, south, east, west. On the 10-sided, north, south, east, west. That's a little different, okay? The 8, this one, and the 12 are very, very similar to each other. The 8 and the 12 always have those cardinal locations of the verts, and that's important for us. It's important for us because it produces an absolute center line, both horizontally and vertically for these cylinders, okay? That is good modeling. We want to have center lines because now we can make symmetrical shapes very easily and create a predictable system for us to connect points into, okay? I mean, look at this 10-side right here in the center. That's just kind of weird, wacky, and strange, if you will, okay? Because I wouldn't even know where to begin with this guy, okay? I could slice it down the center, but how would I slice it over here? That's kind of weird. Yeah, it works, but I'd much rather have an absolute center line cruising down the middle of the shape. In addition, this 10-sider is kind of circular, right? But having those two verts that establish the left and right edges kind of squares out the shape a little bit. So the 8 and the 12 are far superior because they ultimately create a perfectly circular shape with a very predictable pattern around them, okay? We want to work with cylinders that that are created kind of in the powers of 4, right? So 8, 12, 16, what would be another good one? 20, there we go. Yeah, there has to be a 24 is the next one. Okay, there has to be a really, 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 really good reason for me to make a cylinder that has more than 20 sides with it, especially given the power of our subdivision surface modeling techniques, okay? I'll be honest with you, most cylinders that I create are 12-sided cylinders, okay? The Sub-D engine is so strong, and that algorithm is so important to our workflow that there's really not a reason for us to create something that's higher than 12, okay? We can do a majority of the work with relatively simple geometry paired with that Sub-D engine. All right, so let's spend some time talking here, and I want to center this all up. There we go. So now this little circle is centered at the origin of the scene. Let's spend some time looking at how we can take this circle and connect it into a square, okay? As I mentioned before, this is something that 3D modelers, we do all the time. Connecting different surfaces together and different geometric shapes together is kind of how we earn our union card, okay? This is our job. It's our responsibility. So let's look at the technique. The technique is pretty simple. It requires us to do some counting, though. If I have an 8-sided circle, I need to have, an 8-sided circle, I need to have a square that has an opening in it that has 8 sides, okay? So we always have to have a structure that's got a hole in it. This is going to be the connector, or the connection point. So let's create our square initially. Okay, I'm just going to make a perfect square, and then also center it inside of my 3D scene, okay? Now, on my square, I need to create a hole, an opening, something that's big enough that I can click my circle into, that I can join the edges to. So in order for us to make an opening, what do I need to do to my square? What do you think I need to do to that square before I can create an opening? Not so much bevel it, but we need to slice it. I need more geometry on the inside of my square that I then can delete to make a hole, right? I'm going to use the loop slice command to get me what I'm after. Because loop slice, especially when we pair it with the uniform mode, okay, allows me to very quickly slice in some extra detail. So I'm slicing it horizontally now, and I have 4 rectangles connected to each other. I'm going to do it one more time with the exact same settings, and in essence, I'm creating a 16 polygon square grid, if you will, a 4x4 grid. Now, if you look very carefully on the inside of my square, I have 4. No, my circle's getting in the way. Let me hide it real fast. Let me hide everything. Oops, that's not going to work. See if I can just grab my circle here. It's futile. Okay, but I have, there we go. I'll zoom in and just grab the corners of the squares that I want. I have 4 squares in here that I can delete. I want to make my circle a little bit smaller so it fits in that opening. Okay? And this is the goal. We need to physically have a hole inside of a square, right? Think of it like this. We're literally putting a round peg in a square hole. How is this going to fit? How are they going to work together? Okay? And this is where the math part comes in, because in order to connect these 2 pieces cleanly together, I have to have the same number of sides on both. On both the circle, I've double-clicked on it, which selects the entire opening, or excuse me, the entire circle. The bottom right-hand corner of my viewport tells me how many edges I currently have selected, which is 8. Okay? So I have an 8-sided circle. How many edges do I need to have on the interior of that opening, on the square? 8. They need to match. 8 on the circle, 8 on the opening in the square, so I can connect them together. Let's prove it. If I double-click on the opening of my circle, or my square, excuse me, you can also see that the computer tells me instantaneously that I have 8 edges. Okay, so this is going to work. Yay! Awesome. Now, in order to make the connection between the two, we're going to introduce a new tool, okay? And it's called the bridge tool. It's awesome. The bridge tool basically allows us to connect between the edges, okay? I want this shape up here, the circle, to remain in its current location, but I want to fill the gap with a polygon, okay? This is not the P key. This is something different, okay? The bridge command is going to take and look at an edge selection and put a polygon in between just those 2 edges. So naturally, we've got to start our entire operation here with a selection. I'm going to grab both those edges, and then you'll find the bridge tool in a number of different places. It's actually a pretty popular tool. It lands in a couple areas, but most importantly, it's in the basic tool collection, and it's right there. Now, the bridge tool requires you to turn on the tool, but then to click in the viewport to activate the tool and apply it to the scene. And there we go. Ta-da! We've now connected that edge, and we've bridged the gap. So we can just work our way around bridging. Whoop. Or we can double-click on the opening, and I'm going to deselect that one and that one. Okay, basically the caps of the opening, and I can bridge at the same time. Okay, so we can do big groups or them individually. And now I have exactly what I'm after. I have a surface here in the center that is circular. I can bevel it up, and it's all one connected piece. Okay, hit the tab key, get smoothed out, and now we're starting to create that radius that we're after. Everyone do this real fast. Everyone create a circle and a square just like I did and bridge them together. Create a 4x4 cube, delete the center, create a circle inside the cube, then bridge them together. Get this to work. Don't leave today without this working. Yes, sir. So you're lucky. You have a pretty good idea of what it's supposed to look like, but now you need to rebuild them so they're all connected. Mm-hmm. You can if you'd like. Yeah, but you're going to have to rebuild them using this technique. And to help you guys out, I have a great visualization of what this process is supposed to look like. So if this helps, this is in every sense kind of like the steps that one goes through. But physically put these things together real fast, okay? In every sense, this is one of the foundation level ideas for 3D modeling as a whole, okay, is this idea of connecting things. The big takeaway in all of this is that we have to have an even number of sides on both the circle and the square itself. Now, this is a great visualization of how dense your mesh needs to be in order to slice in, or excuse me, in order to connect in a higher resolution circle. And you can see some of the challenges that are associated with that. With an 8-sided circle way at the top, the resolution of our square mesh, relatively thin. But it logarithmically gets more complex and more dense the higher the number of sides on our circle is, okay? So we got to watch it. Okay, we just can't have, a cylinder with 24 sides and expect to slice it into a square easily. More points, more problems, okay? Now, when we're done with all this entire thing, what we get in the product of all of it, something that's really kind of cool. Because now, here's my little example. Now, if you check it out, we can get something that looks pretty neat, okay? And that's pretty fantastic, okay? If you look at the unsubdivided mesh here, I've gone ahead and done some beveling at the top and at the base to control the radius a little bit. Oops, excuse me. There it is, okay? And it's looking pretty great. This is what you're going to be practicing for your Lego brick, okay? Is that we're going to be creating a whole network of these little squares that maybe we can bridge together, okay, to create the outside of our Lego brick. Okay, it should be pretty fun. I think you guys are going to dig it. Okay, that's going to be your homework this week. So it has to be one contiguous piece for your Lego brick. Okay, not a whole series of cylinders kind of stuck in the top of a rectangle. They all need to be connected to each other. You now know the technique, so you should be able to take this and kind of scale it up, if you will, and multiply that idea across an entire Lego brick. Now, I have a couple minutes left in class today, and I want to spend some time talking about a homework. Because our homework this week gives us a really great opportunity to do something fun, okay? And our homework this week is, I scrolled by, is the Ferris wheel, okay? Your mission this week is to create your own Ferris wheel. Mama Bird is kicking you out of the nest, okay? Actually, I'm like shoving you out of the nest, okay? And it's time to start flying on your own. It's your job this week to design, create, texture and render your own Ferris wheel. I'm not giving you any sort of reference. It's your job now to start being a subject matter expert and create something that looks like a Ferris wheel. Okay? Now, what's the first step in this process? Research. Correct answer. And I like that's what you guys said. Research, research, research. In every sense, you need to become like a little mini subject matter expert on what a Ferris wheel looks like. Upon examination, you can find pretty quickly that the Ferris wheel is really nothing more than a whole series of repeating parts going around a central axle, right? So a quick Google search. Let's just do it real fast. Ferris wheel. If we just look at the imagery here, boom, look at all the imagery that I can easily find within just a simple Google search that will give us some really great actionable information as to how this thing looks, okay? Now, this is a good starting point, but look at all the different variety that we can see in here. This is pretty cool, right? Your Ferris wheel just needs to suspend disbelief. It doesn't have to look like any one of these, okay? It can be your own Ferris wheel. Theme it out. The ones that are really cool have a really kind of embedded theme in the actual model file itself. I had one semester, someone turned in it was like a manta ray Ferris wheel, or each one of the gondolas looked like a little manta ray, right? And he actually put it in the ocean. He made this really great big ocean plane. And as the idea was the manta rays would go into the water, and then the thing would turn, and the mantas would go out. It was really kind of rad. It was cool. So you put your own fingerprint and creativity into the model itself, okay? There's a lot of room in here to be creative. So take the opportunity, take the room, be creative in this, okay? I like these down here, like this one. Cool flower shape on the inside. There's some opportunity to create some really engaging patterns that will make a pretty neat effect. So the big question that we got to ask ourselves, technically, artistically, you're going to have some fun with this, but technically, how do we create efficiently a network of polygons that all get duplicated around a central axle. Okay? Now, we've been dancing around this idea for a little bit, and if you go back in time to the beginning of the semester, specifically to the Parthenon assignment, we spent some energy looking at how we can duplicate objects in a straight line. But now that we're going to be making a Ferris wheel, how do we duplicate things in a circle? Good idea, right? Because the smart modeler, which all of you guys are, okay, would create one portion of the Ferris wheel and then duplicate it, okay? For us, inside the world of Modo, we're going to be performing what's called a radial array. And I think what I'm going to do here real fast is that I'm just going to have this thing. Okay, this is going to represent like the axle. I've placed that axle of my Ferris wheel in the center of my scene at the origin. Hint, hint, nudge, nudge, hint, hint, nudge, nudge. The origin is es muy importante for this assignment, okay? So this is the central part. This is the axle of the Ferris wheel. And I'm going to have a whole series of arms that come off of this axle. Let me just make something real fast. I have no idea what I'm going to make. Let's just do it real fast, okay? Maybe I have these really fun, I don't know, what am I doing here, Pat? I don't know what I'm doing. Here, I'm going to do this. There we go. That's a little crazy. That's actually a whole lot crazy. Let's do this. I'm being a 3D modeler now, and I should know better. There we go. Maybe I'll even slice it on this side, kind of like bridge the gap. I don't know why, just because that seems interesting. There we go. There's my model. Okay. Let's give it some depth. Something like that. So it's kind of like a little fan. I'm just making something interesting here. And I'm also going to center this along the z-axis. Okay, there we go. All right, so let's just pretend that this is one of the arms for my Ferris wheel, and I need to have a whole bunch of them, right? Let's say like 12, okay? How are we going to do this? Well, this is where the radial array tool inside of our duplication series of tools really come in handy. Check it out. Now, please note, I'm using the origin action center. The central hub is at the origin. I want to duplicate around the origin to get a real precise circle of duplicates, okay? So I got my little fan, my little blade selected here. And under our duplication collection of tools, we have radial array. And this is it. This is the one that's going to do all the work for us, okay? This is like the clone tool, okay? But the radial array makes duplicates in a circle, which is what we're after. Let's fire it off. Since I'm using the origin action center, the center point of my radial array is going to be right in the middle of this circle. And there it is, okay? Zoom out, you can see what we're working with here, okay? Now, before I drop the tool, of course, naturally, I can increase the number of duplicates. I think I said I wanted to have 12 before. I can even go down to like 3, 4. That's kind of fun, okay? When you're working, make sure that you're duplicating along the correct axis, much like we saw earlier with the radial sweep. For me, I want to do this array around the z-axis, but we can get some pretty abstract shapes, There it is around the y-axis. Okay. If you look at the tool properties, there's some other fun things in here. Let's say we only wanted to do like half a circle, right? So the end angle 180 degrees versus 360. You can see what we're creating here. Ever wondered how they do spiral staircases? They use a radial array. However, the one thing that they change here is the offset amount. Okay. This is going to raise each duplicate up towards the sky based off of whatever value that I put in here. Let me show you what I'm talking about. There we go. Now I have the beginning of a really cool spiral staircase. Okay? Or I could just put this to 360 degrees, put my count to like 60. There's all the treads for my stairs. Cool, huh? Very cool. The radial array tool allows us to make copies in a circle. However, let me put my count back down to 12 around the z-axis with 0 offset. However, the product of all of this can at times be very problematic, okay? Check this out. What if I needed to make a change? And if you look carefully down here, I have some bad modeling going on, right? You see how it crosses right there? That's driving me crazy. I don't want my geometry to cross. That suspends disbelief pretty quickly, okay? Or breaks the illusion pretty quickly. So I need to make a change, but I have 12 of these things now. They're all polygons, right? I could go in and do this, but when I get over here, it's like, what angle am I going to do that at? You know, ruined, bad day, okay? Let me show you a great alternative that will help you in this process, and this is kind of neat. It's called instancing, okay? I want to go back in time a little bit here, and I want to put this blade of my wheel on its own mesh item. And this is important. It has to be on its own mesh item, because in instance, we're going to duplicate the entire contents of an item now. So I just want to have one of the blades of my Ferris wheel be in that own item. And I'm going to cut the geometry and paste it into its own item. Okay. So now I'm going to do the exact same thing that I did before. However, still leave my action center at origin. This time, here's the radial array. I'm going to hold down the Option key. See how it goes pink? The instance radial array is pretty special. Same rules apply. Bloop, there they all are. But now, watch what happens. Instances are special because the geometry of each instance item is being referenced from the original. Point being, any change that I make to the original will automatically propagate to all the instances. Okay? Which allows me to very quickly make changes on one and have them all update at the exact same time. Okay? Shoot, let me prove it to you even more. This is cool. I can grab those. I can continue working. Just a couple little bevels. Now we're on our way. Okay? Now, when it comes time to render this, all the instances render as first-class citizens inside of our, here they are. Okay, pretty neat. The instances allow us to model one and have all of the duplicates update whenever I make a change to that original. Pretty neat, huh? Pretty neat. I like it very much. So this is your mission this week, okay, is to make a Ferris wheel. Now, there are a couple specific expectations that I would like you guys to strive to achieve on the actual Ferris wheel itself, okay? So, 12 gondolas, that's the places where the people sit, right? Got to have 12 of them. So you're going to do at least 12 arms of your entire Ferris wheel. The other thing that you're going to be asked to make is some sort of support structure, so it's not just the wheel. We need to start suggesting to the audience how this wheel is connected to the ground. So some sort of frame, if you will, an A-frame or whatever it is that you want to create that attaches your wheel to the ground so it doesn't want to fall over, because that would be bad if the Ferris wheel fell over, right? Especially if you're on it. Yeah, that's a lot of lawsuits. It really is. No lawsuits in GCOM 402, okay? So a support structure, a frame, something to illustrate a base, and then, of course, geometry for a simple scene, okay? Be creative with this assignment. I wish I could, I don't know why they're so small. I wish they weren't so small. But here's a great example of someone being very creative. It's kind of a spooky Halloween Ferris wheel, okay? There's a lot of room in here to do something creative and fun. Take the opportunity. Make something creative and fun, okay? Go as far with it as you'd like, okay? A suggestion, try to create a complete picture, okay? Try to create a scene that really kind of fills in the blank. You want your artwork to stand on its own, right? You don't ever want to have to say to someone, well, you know, I wish I had done that, or I wish I had done this, right? Make a complete picture that doesn't require any sort